here I have my MATLAB program that uses ABCD matrices to model and visualize an optical system. So each optical element is like a free space region or lens, and it's represented by its corresponding 2x2 ABCD matrix. The system then multiplies each, so in this code, the system multiplies each input ray by these matrices in a sequence to calculate how the rays propagate through the elliptical system. And if I run the code here, you see how each of the 3 distinct rays are traced throughout our system. It's a little small, so I can zoom in to look at them closer, how they actually propagate. And so the blue dashed line on our system marks the positive lens, and the red dashed line is the negative lens. And so the rays bend accordingly, converging or diverging depending on each of the focal lengths. And so I can also change some of my parameters in my code. For example, I can change the focal length. And in this case, I'm going to change f2 to 60, and that is going to change how my system is run. So the parameters are pretty easy to modify. So when I changed f2 from a negative focal length to a positive one and reran the program, if you zoom in, I have to zoom in even more, but if you zoom in, you see how the rays now converge a little differently. And so this changes the overall optical behavior of the rays. One thing I can also do is I can also change the initial height or angle of the input rays. Let me demonstrate that. So this one's at so my first ray is at 0.02 millimeters. So I can make that 0.1 millimeters and then run. And then you can see how this input ray, it changes accordingly and recalculates their path throughout both of these matrices. So in summaries, the plot shows the optical axis in millimeters and limits the ray height to plus or minus 20 millimeters for clarity. So each of these ray paths is clearly labeled with their corresponding heights, and the lenses are annotated with their focal length. So this program demonstrates how an ABCD matrix method can be used to simulate and visualize complex optical systems in MATLAB. So thanks for watching.